Okay, now let's look at number 3 from these adding fractions and rational expressions or subtracting. And this one turns out to be a little bit trickier than number 1 or 2 was. I think number 2 I did. And that's because of a domain issue here. So we can see that the denominator has no common factors. This is x plus 4 times x minus 4, and this is x minus 13 times x minus 1. Factors have to be either 1 or 13, and they're not going to work here. So we have no common factors. So we could go ahead and multiply the numerator and denominator here by x squared minus 16, and do the same thing here, multiplying by this expression, and go through all the algebra, and that'll work. And we'll end up with a solution. But let's factor the denominators first here. This is x minus 1 over x minus 1 times x minus 13, right? Minus 4 over x plus 4 and x minus 4. Now we can see that in this expression we have a factor we can cancel, but we have to be careful when we cancel this, because x in this problem cannot be equal to 1 or 13 or 4 or minus 4. These are not in the domain. If you put any of those numbers in, you'll have a 0 denominator. So the original function does not include this point. So let's go ahead and cancel it. But when we cancel it, we do have to make a note of this, because we shouldn't have it in our final function either if it's going to be equivalent. Now we have 1 over x minus 13 minus 4 over x plus 4 times x minus 4. And we can do this like we did the last one. Actually, I'll let you go through that. If you're working on these, you should be able to do this algebra. You'll get x squared minus 4x plus 36 and over x minus 13 times x plus 4 times x minus 4. So this is an equivalent function as long as you are excluding these numbers here. If you don't make a note of that, now 1 will work. If you put 1 in here, it's going to work. You don't have a domain problem. In your original function, it did not work. So they're not quite equivalent in terms of domain, and that's why you need to make a note of this when you cancel this up here. If you don't do this, you'll end up with a longer expression with a cubic on the top, and it'll be an equivalent expression because there will be an x minus 1 in the bottom. It'll still be there. It'll be in the top and the bottom. And you can cancel it at that point, but once again, if you cancel it at the end rather than the beginning, you need to make a note of that. And you need to specify that that point's not in the domain. So this one turned out to be a little bit tricky because of this domain issue, and you have to be careful of that, because sometimes the domain of your result will not be the same as the domain of the original problem if you're not careful.